Good evening, everyone.
Good evening, sir.
So we continue with today's class. Today we have to start with in electricity. We had started. We just started with charges and current, right? So in the last class we had done about current. Did we do about electric potential?
Yes.
Yes, we did about electric potential, right? Just one. Yes, the system today is taking a little bit of time for starting. So just 1 minute. Okay, so let me share here. We had a class yesterday also, right?
Yes, sir.
Yeah. So 13.
Sir,
Yes.
I may not respond today due to background disturbances.
Okay. Sorry. Watch pictures. Right? Yeah, so this is the topic we had done in the last class. Yeah, we had done the rate of flow of charges. We had seen that the electric current is the rate of flow of charges. Today we'll look up what is electric potential. So current is defined as the rate of flow of charges, how fast the charges are moving through a wire. Yesterday we had also discussed that a wire has free electrons and bonded electrons. A wire has free electrons and bonded electrons. So whatever bonded electrons are there, bonded electrons do not participate in any any current, but it is only the free electrons which are not bonded. They are the only ones which help in the transfer of charges. Okay. So here, more the number of free electrons, more will be the conductivity. So on this basis, we can also tell that which substance will be a conductor and which substance will be an insulator. A substance which has a good number of free electrons, that will be a conductor, whereas a substance which has a lesser number of free electrons will be an insulator. Got it? Now today we study about electric potential. See the word electric potential or potential difference. First we see potential difference. What is potential difference? Electric potential and potential difference. So we had seen here that a similar term related to potential we have studied in our previous classes also. So can anyone tell what is potential? Yes, Siddharth, can you tell what is potential? Yes, Siddharth. Siddharth. Siddhisri. Siddhisri, have you heard anything about potential?
Sir, is it correct?
Potential. No, not charges, nothing, anything which we have studied earlier regarding potential. Yes, anything which we have studied regarding potential. There is.
Yes, sir.
Yeah, what is potential energy?
So potential energy is like the amount of energy present in an object or yeah.
Amount of energy. Yes, yes.
1 minute, sir.
Siddharth, are you able to respond? Siddharth. Okay. So see, first we try to define what is potential energy. We see that potential energy is the amount of energy possessed by, it is the energy possessed by a body due to its position or shape, position or configuration. So the energy possessed by a body due to its position, shape or configuration, we call it as a potential energy. So we have done this with the different objects, that the different objects they possess potential energies. For examples, if you look for, okay Siddharth, thank you for responding now. Okay. So it is the energy possessed by a body due to its position or shape or configuration. So when we say potential energy, it is due to the change of shape, position, size, configuration, shape, position and size. So we have learned about gravitational potential energy. So does anyone remember the formula for gravitational potential energy? See, the gravitational potential energy, suppose we take a mass of m and we move it to a certain height h. Okay. So we have a mass m and it moves to a certain height h. So the gravitational potential energy over here, so the gravitational potential energy is given as mgh. Okay. mgh, that is the potential energy stored in this against the gravity. We have done our work against the gravity. So we observe that our work done is equal to mgh, and this is the potential energy. Now, what about a spring? Does a spring also possess potential energy? Suppose here I have a spring and this is the original spring and I compress it in a very small space like this. So if I compress this spring, so there is an extension, there is a compression in the spring. So do you think that the spring also possesses some amount of energy?
Yes, sir.
Yes. So which type of energy? Which type of energy? The spring possesses.
Elastic
Yeah.
potential, something goes like this only, sir.
Yeah.
Elastic potential energy.
Yeah. This the spring also has a potential energy. What about this one slingshot? If you have a slingshot, so a slingshot, which type of energy is possessed by a slingshot? The slingshot also possesses potential energy. As all these energies, they are possessed due to their shape, they are possessed due to their configuration, they are possessed either due to their position. Okay, so these are all the forms of potential energy. In just like similar to this, we also have electric potential energy. We can also define electric potential energy to be something like this. See? We can define electric potential energy to be something like this. Let's say we have a charge. Let's say we have a charge here, a positive Q. We have a charge of small q. Here we have a small charge. And let's say I move this small charge I want to move this charge from this point to another point here. Okay. See, both the charges are negative. Both the charges are positive. Sorry, I consider this charge as the positive charge. This charge is also a positive charge. Okay, so I am trying to bring this charge from this point A to the point B. Okay, so do you think that the charge which I have taken a positive charge of plus Q naught. Naught means it's a very small amount of charge. Okay, so I have taken a very small amount of charge which is moving from point A to point B. So when this charge moves from point A to point B, do you think that I need to do some work to move this from point A to point B? Yes. Arav? Arav?
Yes, sir.
Do you think we need some force to move the charge from the point A to point B?
Yes, sir.
Yes, we need to move the charge. If we are moving the charge from point A to B, I am doing some work. So I will write it as I have done some work. My work I write as work done from A to B. So this is the work done by me from A to B. So can I say that this work done will be stored in the charge in the form of potential energy? Yes, Aryan?
Sir,
Yes. Is it? Can I say my work done will be stored in the charge in the form of potential energy?
yes, sir.
Yes. So isn't it the similar to the gravitational? Like here you lift a mass to a certain height. So you do some work and that work is stored over here in the form of potential energy.
Yes, sir.
In the similar way, here we have a charge, positive charge plus Q naught placed at point A and we are moving it to the point B, which is closer to this charge. So this point B is closer to the charge. So if I am moving this charge plus Q to the point B, definitely I am doing some amount of work. Okay. So that amount of work which I have done, it is stored there in the form of potential energy. And just similar to the gravitational potential, like if you release the stone or mass from here, it will fall downward and it will gain kinetic energy. It will gain speed. As it moves down, it will gain kinetic energy. The similar thing will happen here also. You pushed it to the point B, and if you release from point B, it will travel towards the point A. So the charge will travel towards the point A. That is, its potential energy will get converted into kinetic energy. I will get my work done back in the form of kinetic energy. Got it? Yes. So this is from this forms the fundamental for electric potential. So I think everyone has understood about the electric potential energy. Just like the other forms of other types of potential energy, like potential energy in a rubber band, potential energy in a slingshot. We have seen potential energy in a spring. We have seen potential energy in uh, we have seen potential energy in a mass. So just like that, you have a total potential energy, which is the similar in the case of electric charges, which we also call as electric potential energy. Okay, so this is electric potential energy. But what is potential or potential difference? The potential or potential difference, which we generally write as PD, it is equal to the work done from the point A to point B per unit charge. This is potential difference. This is potential. So there is a difference between potential and potential energy. Understood the two terms? Yes, potential and potential energy, they are two different terms. Got it, Sumuk? Sumuk? Sumuk?
Yes, sir.
Okay, so did you get the difference between potential and potential energy?
No, sir. I joined late today.
Okay. So see, the electric potential is the amount of work done per unit charge. So here we have seen the potential difference. The potential difference is equal to work done per unit charge.
Yes, sir.
So potential difference is the work done per unit charge. Then, so we define this electric potential difference something like this. All of you be active and alert. Be active during the
Yes, sir.
classes. If any query is there, do respond it. So potential difference, it is the work done per unit charge. It is the work done per unit charge in moving a charge from one, or we can say from point A to point B. So it will be equal to the potential difference between the points A and B. Okay, so I can also write it like this. I can also write the same thing. The potential difference between the 2 points, let's say the potential difference between the points A and B is the work done per unit charge in moving a charge from point A to B. Just the similar thing which we drew in the previous diagram. The same thing if I can draw here, like I have a positive charge here plus Q, positive charge of plus Q. I have a small charge over here which is again a plus Q naught. So when I move this charge, let's say this is a positive charge again plus. So if I'm moving this charge from this point A to another point B, I'm moving like this. So I need to do my work done. This work done from A to B per unit charge is equal to the potential difference V between the points A and B. I also write it as VAB, which is the potential difference between the points AB. So the potential difference between the points A and B will be equal to the work done from A to B per unit charge. The SI unit of electric potential, here we obtain electric SI unit of potential difference. Potential difference is volt. SI unit is volt, written as V. So it can also be written as coulomb per second. I can also write it, the volts to be same as, the volts can be written as coulomb per second. They are equivalent. I can write it as coulomb per second. Got it? Understood this? SI unit of potential difference is volt, and this is the same as coulomb per second. As I can write here, V is equal to W over Q naught. Sorry, not coulomb, joule per. It's joule per coulomb. Sorry, not coulomb per second. Just let me correct it. It's joule per coulomb. So joule per coulomb or volt, they are the same thing. Here V is equals to W over Q. So we can do some small questions like, let's say we have a question here. What will be the work done? What will be the work done to move a charge of of 2 coulomb through a potential difference of 12 volt. Okay, try out this question, everyone. Try out the question and write your answer in the message in the chat section. Yes, anyone got the answer? I just got one answer. Yes, Ionija, your answer is correct. No other answers. Okay, anyone else? Yeah, one more answer. I think. Yes, Siddharth's answer is also correct. Siddhisri, okay. Abhinav, Sumuk, Sumuk, what about your answers? Abhinav and Sumuk, did you get the answer? Abhinav?
No,
Okay.
sir.
So I, okay, Abhinav, Sumuk, Aryan. Okay, see, it's very simple. You just need to use the formula V equals to W over Q. Here the potential is given as 12 volt. So we use potential difference as 12 equal to W, which is work done, divided by charge, which is 2. So 12 multiplied 2 will be equal to the work done. 12 multiplied 2 is 24. So you get 24 joule is equal to work done. Got it? So answer is 24 joule. It was quite simple, not a mix up of the formula. Okay. The next is we
Got
need to
it,
see
sir.
some electric symbols, and before the electric symbols we study two important devices for measuring these. So two important devices, I think, let me check, we haven't done this. Okay, the two important devices, they are ammeter and voltmeter. So let's write here ammeter. So ammeter, it is a device it is a device which measure current. Measure current, and the current is measured in ampere. Then you have voltmeter. So voltmeter, it is a device that measure electric potential. Electric potential between 2 points. So the device which measure electric potential between the 2 points, that is a voltmeter, and a voltmeter is always connected in parallel to the circuit, whereas an ammeter is always connected in series to a circuit. So also an ammeter has low resistance. If you talk of an ideal ammeter has an infinite resistance. So an ammeter has a low resistance, whereas a voltmeter, it has infinite resistance, or it has high resistance. So a voltmeter, it is a device that measure electric potential between 2 points. It has a high resistance. And an ammeter, it has a low resistance. That is also the reason why we connect our ammeter in series and a voltmeter in parallel. So in any circuit, suppose we make here a circuit. So in a circuit, we always connect an ammeter. Okay, Abhinav, you are got it. Okay. So Abhinav, did you get the solution now?
Yes, sir. I said right, I got it.
Okay, see. Now the two devices, ammeter and voltmeter. Ammeter is represented by the symbol A. It's represented by a symbol A in the circle, and two terminals of the ammeter having positive and negative terminal. Voltmeter is represented by the symbol V, having a positive terminal and a negative terminal. So again, let us see how I connect the ammeter and voltmeter in a circuit. So see how I connect the ammeter and voltmeter in circuit. Let's say we have a bulb working over here. The bulb being connected with a cell or a battery. Here we have an ammeter, a switch, a battery. So the ammeter has two terminals, positive terminal and negative terminal. We have the switch, battery having positive and negative, and this bulb. Now where should I connect the voltmeter? The voltmeter should be connected in parallel to the device where I want to measure the potential. If I want to measure the potential across the bulb, I'll be connecting it across the bulb. Let these points be A and B. If I want to measure the potential difference across this battery, so I'll connect my voltmeter like this. I'll connect my voltmeter in parallel to the battery. So anyway, wherever the voltmeter is connected, it will always be connected parallel to the electric component. Whatever the electric component is there, so it will be connected parallel to that electric component. Ammeter, it is connected in main circuit wherever I want to measure the current. Suppose I connect here two bulbs Let's say I connect here two bulbs. And now I want to measure the current flowing through this bulb A. So I'll be connecting my ammeter in series to this bulb A, maybe before it or maybe after it. If I want to measure the current through the second bulb B, so I'll connect my ammeter here in the second circuit. Okay. If I want to measure the potential difference across A, so I will connect my voltmeter something like this across A. If I want the potential difference across B, so I'll connect the voltmeter like this. Got this? How to connect the ammeter and voltmeter?
Yes, sir.
Okay. So with this, you get some small questions in your board exams. You may get that the questions may contain a circuit diagram, and they might ask you to find out that which one diagram is correct and which one is incorrect. Okay. So see what all things you need to take care here. You need to take care that your voltmeter should be connected in parallel. Your ammeter should be connected in series. Then you need to check the terminal. Terminal means the positive terminal of the ammeter should be connected to the positive terminal of the battery, and the negative terminal of the ammeter should be connected to the negative terminal of the battery. Got it? Got it? So this voltmeter, its positive terminal connected to positive of the battery, negative terminal connected to negative of the battery. So this is how your a circuit is drawn. This you can also call it to be a simple circuit consisting of a switch, a cell or a battery, a bulb, an ammeter, and a voltmeter. Almost everything is there. Okay. Let us try to learn some circuit symbols. I think most of the circuits are aware with. So in the circuit symbols, the first symbol we see is our cell. Then we see battery. We see resistance. Switch. Then a meter, which we just drew, voltmeter. These are the some of the components of the circuit. You may draw a bulb, then a fuse. You have a, this resistance we call as the fixed resistance. So let's draw here, right, fixed resistance, and we have a variable resistance. Variable resistance or rheostat. So variable resistance or rheostat. So what are the symbols here? See, a cell, it's represented like this: positive terminal, negative terminal, positive terminal, again negative terminal. So like this you can represent. But a single cell will be represented just with a one vertical line which is bigger, other vertical line which is smaller. The bigger vertical line represents a positive terminal. The smaller vertical line represents a negative terminal. A battery is represented as a combination of cells. So you can make a battery like this: 1, 2, 3, 4. So this is now one cell connected to the other. It forms a battery of two cells. In the same way, you can make a battery of three cells by connecting three cells in series to each other. All right. Okay, so we'll continue with this. I think the time is up. So we'll continue with this in our next class. Take rest. Thank you and happy learning for your concentration.